Here is the second video for the second half of the problems I gave you. Ignore the numbers on mine, yours don't match up, so we'll just talk about the problems and ignore the numbers. For the first one, it says the graphs of the piecewise linear functions f and g are shown above. If the function h is defined by h of x equals f times g, then h prime of 2 is blank. So again, if we're trying to find the derivative, we need to use the product rule. The product rule says that u would be equal to the first function f of x, and that v would be equal to the second function g of x. U prime is f prime of x, and g prime is g prime of x. Oh, sorry, u prime. And v prime would be g prime of x. Now if I'm trying to evaluate it at 2, put these points on the graph. There's the point on f at 2, here's the point on g at 2. So f of 2 is equal to 4, g of 2 is equal to 5. And I can tell that just by looking at these dots on the graph. Now the derivatives, remember, because these are straight lines, their derivatives are the slopes of the lines themselves. So f prime of 2, slope of the tangent line would be up 2 over 1, so that's positive 2. And g prime of 2 would be up 1 over 1, that's positive 1. Product rule says to multiply backwards first, so if I multiply those I get 10. And then plus multiplying forwards, 4 times 1 would be 4. So 10 plus 4, which is 14. Answer choice C. For the second one, it says, given all the table values up above, and that h of x is equal to this whole thing, then h prime of 1 equals blank. Now, if you read this carefully, it says that, oh, excuse me, those are my dogs. It says that h of x is equal to 2 times f of x, and since 2 is a constant multiple, we don't have to worry about any special rules there. 2 times f of x plus 3, and then times 1 plus g of x. So since this entire first set of parentheses and this entire second set of parentheses has x's in it, and we're multiplying them, then we have to use the product rule when we take the derivative. So I'm going to go ahead and say that my first function u is equal to 2 f of x plus 3, and my second function v is equal to 1 plus g of x. So when I take the derivative of u, because 2 is a constant multiple, it just tags along for the ride, so it's just 2 times f prime of x. Now 3 has a derivative of 0, so I don't need to worry about that. And then v prime, the derivative of 1 is 0, and then g prime of x. So if I'm trying to evaluate this at x equals 1, then I'm going to go ahead and evaluate that now. So for this first one, it would be 2 times some number plus 3. So if I want to know what f of 1 is, I would come up here to the chart, and I would say, okay, f of 1 is equal to 3. So I'm going to plug in a 3 right there. For this next piece, it would be 1 plus some number. I want to know what g of 1 is. So g of 1 is equal to negative 3. For this next one, it's 2 times f prime of 1. So from the chart, f prime of 1 is equal to negative 2. And then down here, g prime of 1 is equal to 4. So if I simplify this stuff a little bit, for this first one, I get 2 times 3 is 6. 6 plus 3 is 9. For the next one, I get 1 plus negative 3, which is negative 2. 2 times negative 2, which is negative 4. And then 4 simplifies to itself. So if I'm multiplying backwards first, and this is product rule, not quotient rule, so I'm going to add. If I multiply backwards first, that's negative 2 times negative 4, which is 8, plus, since it's product rule, multiplying forwards, 9 times 4, and 9 times 4 is 36, and 36 plus 8 is equal to 44. Answer choice D. For this next one, they want to know the derivative of h, and this time it's f divided by g, so we're going to use the quotient rule. So I would say u is equal to f of x, and g is equal to, v, keep doing that, v is equal to g of x, u prime is f prime of x, v prime is g prime of x, and if I'm plugging in 0 now, and I go to the table, f of 0 is 3, g of 0 is 2, f prime of 0 is 4, and g prime of 0 is pi. So quotient rule says to multiply backwards first. 4 times 2 is 8, minus, multiplying forwards, 3 times pi is 3 pi, all over the bottom squared. And so since the denominator is 2, 2 squared would be 4. So 8 minus 3 pi over 4, answer choice A. For the next one, it says, let f be the function defined above. Which of the following statements is true? And if you look at all the answers, it all has to do with something about 5, which is the breaking point. And they want to know whether or not it's differentiable at 5. And then, well, obviously it's not, because every single answer choice says it's not differentiable at 5. So the reason why is what we're looking for. Is it because it's not continuous? Is it because it's not defined? Is it because it has a sharp corner? Or is it because it has a vertical tangent line at 5? So the very first thing we should check for is continuity of a piecewise function. So if I plug in 5 to the first function, I get 2. If I plug in 5 to the second function, I get 2 times 5 minus 4, which is 10 minus 4, which is 6. So automatically, since the left and right hand limits are not equal on the original function, we can say that the function is not continuous at 5. Therefore, answer choice A is the reason why this function is not differentiable. Now, if these had been equal to each other, if this had been 2 or they were both 6 or whatever, then we would go ahead and take the derivative. And if the derivatives were different values, we would say it has a sharp corner from the left and right. If they were different values, we would say it has a sharp corner. The only reason it would have a vertical tangent is if one of the derivatives was undefined, like if it was going to infinity or something. And then last but not least, if the function was not defined, that would be that it was like less than on one side and greater than on the other side, but not equal to. So if it's equal to, then it means the function is defined. So that's not our correct answer choice either. All right, for the next question, it says, which of the following statements, if true, cannot be used to conclude that f of 0 exists? So A, actually just reading A right off the bat, is the correct answer. And here's why. I can draw a picture where a limit exists as you get towards 0. So in this picture, the limit as you approach 0 from the left exists, the limit as you approach 0 from the right exists, and they're the same value. But f of 0 does not exist because it's an open circle and there is no value there. So this cannot be used to prove that the function exists at 0. This one has to be true because remember, this has to be where you can draw the entire thing without ever lifting your pencil off the paper. So if there were a hole in the graph, it better be filled in by a point if it's continuous. Same thing if it's differentiable. If it's differentiable, it has to be continuous. Therefore, the limit has to exist and the function has to exist, and they have to be equal. And then last but not least, the graph of f has a y-intercept. If a function has a y-intercept anywhere on the y-axis, automatically it's 0, comma, some number. Therefore, f of 0 has to exist because the y-intercept is what f of 0 is equal to. So the only one that can't prove that the function exists is if the limit is existing. For this next one, the figure above shows the graph of the function f, which is a vertical tangent at x equals 4. So if I drew it a vertical tangent at x equals 4, it would look something like that. It has a horizontal tangent at x equals 5, something like that. It says, which of the following statements is false? A, f is not differentiable at x equals 2. Well, that's a true statement. It is not differentiable. Let's continue and see what else it says. Because the graph of f has a jump discontinuity at x equals 2. Yep, that's true. It does have a jump discontinuity and therefore is not differentiable. So that is not the correct answer because they're looking for which one is false. The next one, f is not differentiable at 4 because the graph has a vertical tangent. That's true. It is not differentiable at 4 because it has a vertical tangent. That is a point of non-differentiability. The next one, f is not differentiable at 5 because the graph has a horizontal tangent. Now remember that horizontal tangents do not cause issues for differentiability. It's okay to have a horizontal tangent and the function is still differentiable because the derivative is equal to 0. The slope of the tangent line is equal to 0. So C is not a true statement. It does have a horizontal tangent, but that doesn't mean that it's not differentiable. It is differentiable there. So the part that I take issue with is the fact that it says not differentiable because it is differentiable. Last but not least, f is not differentiable at 7 because the graph has a removable discontinuity. That's also a true statement. If it's not continuous, it's not differentiable. For the next one, which of the following statements cannot be used to conclude that f is defined at 1? So the limit as x approaches 1 exists. This is a lot like the problem from 2 problems ago. So that automatically is the wrong answer. A limit alone is not enough to prove that a function is defined or existing at 1. Because I could draw a hole in the graph where the limit exists, but the function doesn't exist at that point, and it is not defined at that point. And again, I'm not going to go over these, I just talked about them. If a function is continuous, it has to be defined at 1. If it's differentiable, it has to be continuous, therefore it has to be defined at 1. And then the last one, the line tangent to the graph of f at x equals 1 exists. If a tangent line exists, that means it has to have a derivative. So I'll draw a tangent line, for example. If I can draw a tangent line on a graph, it means it has to have a derivative, which means it has to be differentiable. And if it's differentiable, then it has to be continuous. So all three of these things are kind of related to each other in that sense. All right, next page. This next one says, for any function f, which of the following statements must be true? If f is defined at x equals a, then the limit as x approaches a of f of x is equal to f of a. That does not have to be true. For example, I could draw a limit. Say this is a. I can draw a limit existing and I can draw a function existing somewhere else, but that doesn't mean they have to be equal to each other. So just because the function is defined at x equals a, like I have here, does not mean the limit has to equal what the function equals. So this one does not have to be true. Number 2, if f is continuous at x equals a, then the limit has to equal what the function equals. That is a true statement. If it is continuous, then that point must fill in that hole. So the picture could not look like that, and that has to be true. So that's a yes. The last one, if the function is differentiable, then the limit has to equal what the function is equal to. Again, that is also a true statement, because if it's differentiable, then it has to be continuous. And if it's continuous, the limit must equal what the function equals. So 2 and 3 have to be true in order for the limit to equal what the function equals. All right, the next one, what is g prime of 3? So again, for a piecewise function, we first need to check continuity. So if I take 3 and plug it into the first function, I get 3 minus 3, which is 0. If I take 3 and plug it into the second function, I get 4 times 3 minus 12, which is 12 minus 12, and that's 0. So it is continuous, and now we can move on to whether or not it's differentiable. So g prime of x equals, the derivative of the top function is -1 when x is less than 3. The derivative of the bottom function is 4 when x is greater than or equal to 3. So automatically I can already tell you that the derivative is not going to exist at 3 because my derivative from my left and my derivative from my right are not equal to each other. Therefore, this function must not have a derivative at 3. So far we've done 3 examples where this is not existent. The derivative is not existent for the piecewise function. And again, it could be because it's not continuous, or it could be because the derivatives are not equal to each other. If these were equal to each other, then that would have been what the derivative was equal to. All right, this next one, I hope you recognize the definition of the derivative again. So they would need to know what f of x is, and they need to know what a is. So the function they're working with here is x to the 1/3. I don't know if you can see that or not, but I know that because it's 8 plus h, where 8 happens to be my a value. 8 plus h, which is f of x plus h, to the power of 1/3. Now you can check to make sure, because this should be f of a. So if I took 8 and plugged it into this function, it would give me 2. So if I do that, if I take 8 and plug it into this function, 8 to the power of 1/3 is 2, because the cubed root of 8 is 2. So this is f of x plus h minus f of x all over h. So hopefully you're able to recognize how they used x to the 1/3 as the function, and a was 8. So remember, definition of the derivative just says to find the derivative. So f prime of x is 1/3 x to the negative 2/3. And f prime of 8 would be 1 over 3 times 8 to the positive 2/3. 8 to the 2/3 would be the cubed root of 8 squared. The cubed root of 8 is 2, and then 2 squared is 4. So this is 1 over 3 times 4, which is 1 over 12. Answer choice B. For the next one, they want to know g prime of 1. So again, hopefully you're on board with what we need to do for these problems. We need to check first to make sure it's continuous. If I plug 1 into the top function, I get 2 minus 2 times 1, which is 2 minus 2, and that's 0. If I plug 1 into the bottom function, I get 5 times 1, which is 5, minus 5, and that's 0. The derivatives, g prime of x equals, for the top function, -2 when x is less than 1, for the bottom function, 5 when x is greater than or equal to 1. Therefore, the derivative is non-existent. I know this is a lot of non-existent derivatives, but I want you guys to get in the habit of checking both for continuity and differentiability. For this next one, they want to know h prime of 1, and they're giving us some information about f prime of 1, and they're giving us some information about g prime of 1. So if I take the derivative of h, notice that there are actually no special rules in the derivative of h. The reason being is that I'm not multiplying anything with x's in it. I just have 5 times f of x, which is just a constant multiple, times the function. I have negative 4 times g of x, and that's just a constant multiple. These are just going to tag along for the ride. So I'm not really using a product rule, which is why I don't need information about f and g from the original functions. So h prime of x is 5 times f prime minus 4 times g prime plus the derivative of 3x squared is 6x, and the derivative of negative 2 is 0. So if I plug in 1 now, h prime of 1, I get 5 times f prime of 1. And they told me that f prime of 1 was 2. Minus 4 times g prime of 1. And g prime of 1 is 6. Plus 6 times, I'm plugging in 1 for x, so plus 6 times 1. So this would be 10 minus 24 plus 6. So 10 plus 6 is 16. 16 minus 24, which is negative 8. Answer choice B. Number 50 is very similar to that one. So again, there's no special rules. We're just going to take the derivative normally. H prime of x would be 3 times the derivative of f prime of x, minus 2 times the derivative of g prime of x, minus 5 times the derivative of cosine. And the derivative of cosine is negative sine of x. So negative 5 times negative sine of x would be positive 5 sine of x. And then last but not least, the derivative of negative 3, which is 0. If I plug in 0 for x, I get h prime of 0 to be equal to 3 times f prime of 0. And f prime of 0 is 3. Minus 2 times g prime of 0, and g prime of 0 is 7. Plus 5 times sine of 0, and sine of 0 is 0. So this whole last term goes to 0. So 3 times 3 is 9, minus 2 times 7 is 14. 9 minus 14 is negative 5. Answer choice B. For the next one, it says, find the value of f prime of 0. And notice that again, here we have 3 times sine of x, and 3 is a constant multiple, so there's no special rules there. 8 times e to the x, and 8 is a constant multiple, so there are no special rules there. So as I take the derivative at 0, I'm just going to be taking it normally. F prime of x equals 3 tags along for the ride, and the derivative of sine of x is cosine of x, plus 8 times the derivative of e to the x, which is e to the x. And then we'll plug in 0. F prime of 0 equals 3 times cosine of 0 plus 8 times e to the 0. Well, cosine of 0 is 1, so this is 3 times 1, plus 8 times e to the 0, and e to the 0 is also 1. So this is 3 plus 8, 11. Answer choice D. For this next one, no special rules. 2 is a constant multiple. 3 is a constant multiple. So we're taking the derivative of f normally. Therefore, f prime of x would be equal to 2 times the derivative of cosine, which is negative sine. So that's negative 2 sine of x. Plus 3 times the derivative of e to the x, which is still e to the x. If I plug in 0, I get f prime of 0 to be equal to negative 2 times sine of 0. Plus 3 e to the 0. Well, guess what? This whole thing is going to 0 because sine of 0 is 0. So this is 3 times e to the 0, which is 3 times 1. Answer choice C. The next one says, what is the derivative of cotangent? This is literally just one of your basic derivative rules. Did you remember and recall what the derivative of cotangent was or not? And can you figure out which one of these it is? And the derivative of cotangent is negative cosecant squared. So you would just put answer choice B. For this next one, we do have to use the product rule because we're multiplying together two things that have x's in them. Cosine of x times tangent of x. So u would be the first function, which is cosine of x, and v would be the second function, which is tangent of x. U prime, the derivative of cosine, is negative sine of x, and v prime, the derivative of tangent, is secant squared of x. Now, we can go ahead and multiply backwards first. So the derivative multiplied backwards would be negative sine of x times tangent of x. And then multiply forwards, so that would be plus cosine of x times secant squared of x. And one thing I want you to notice is that that is not one of our answer choices. So we need to do a little bit of manipulation. So I want you to realize that I can rewrite this as sine of x times over cosine of x, excuse me. One thing I would always highly recommend if you are trying to manipulate something using trigonometry is that you put everything in terms of sines and cosines, because it makes it a lot easier to manipulate and kind of simplify it. It becomes a little clearer. And then for the second one, this would be cosine of x over secant squared, which is cosine squared of x. I can move that back to the bottom since secant is 1 over cosine, so that would be 1 over cosine squared. Now, obviously, I can simplify a little bit here. Sine of x times sine of x would be sine squared of x over cosine of x, plus, over on this side, one of the cosines divides out, so this would be 1 over cosine squared of x. And sorry, this is negative, negative sine of x. Negative, there we go. Negative, perfect. Now that we have a common denominator, I can add these. So this is negative sine squared of x plus 1 over cosine of x. Now, I don't know if you recognize that or not, but that's actually the Pythagorean identity. Remember that sine squared plus cosine squared is equal to 1. So if I subtract sine squared over to the right hand side, that would be 1 minus sine squared of x, which this is. So this is actually equal to cosine squared of x over cosine x. And again, that's the Pythagorean identity. And cosine of squared of x over cosine of x just simplifies to cosine of x. So kind of a long, drawn out answer about how to get B as an answer choice. I'm sure that would have been much easier if I would have simplified from the beginning. So I don't know if any of you guys caught on to that, but I could have simplified this at the very, very beginning. So if I would have rewritten this, if I would have rewritten cosine times tangent as cosine of x times sine of x over cosine of x, because that's tangent, I could have said, oh, hey, look, I can divide that out to be 1. This is just sine of x, and the derivative of sine of x is cosine of x. So that would have been so much easier than doing it the way that I did it. So if any of you guys did it the way I did it, you'll obviously see why. Sometimes it's easier just to convert everything into sines and cosines before you go forward. It would save you a ton of time and maybe also some headache and mistakes along the way. Number 55 says, let f be the function given by cosine of x minus cosecant of x. What is the value of f prime of 1? So I can go ahead and take the derivative of f. F prime of x is equal to the derivative of cosine of x. And actually, now that I'm looking at it, notice that all of these are decimal places, so we're going to need a calculator to find this anyway. We have learned how to find derivatives on the calculator before, so if I can walk you through it verbally since I don't have mine with me, you would enter in this function for y1, so you would say cosine of x minus cosecant of x and enter that in for y1. Then go back to the main screen and click on math. I think it's math option, I want to say it's option 6 or option 8 or something, n deriv, and then you can recall the function y1 and then evaluate the function at 1. So I'm going to do it on Desmos just to show you what the answer is, but on your graphing calculator, I want you to practice finding the derivative there. All right, so here it is on mine. I have f of x equaling cosecant of x minus, cosine of x minus cosecant of x. F prime of 1 is equal to negative 0.078. So that's answer choice C. again, I want you guys doing it on your graphing calculator. I do not want you to doing it on Desmos, even though I don't have mine with me. If you're not quite sure how to use your graphing calculator to find that, please let me know, and I'm more than happy to help you. All right, for this next one, it says, let f be the function given by f of x equals 2x cubed minus 4x squared minus 5. What is the value of f prime of negative 1? So finding the derivative, we get that f prime of x is 6x squared minus 8x. If I plug in negative 1, I get that f prime of negative 1 is equal to 6 times negative 1 squared, which would be 6 times 1. That's just 6. And then negative 8 times negative 1 is positive 8. So 6 plus 8, which is 14. Answer choice D. For the next one, they want the derivative at negative 2. So f prime of x is 15x squared minus 3. If I plug in 2, f prime, negative 2. F prime of negative 2 would be 15 times negative 2 squared. That's 4 minus 3. 15 times 4 is 60. So 60 minus 3 is 57. Answer choice D. For the next one, we have ln of x times cosine of x, and that is a product rule. So when I find the derivative, I have u equaling ln of x, v equaling cosine of x, u prime would be 1 over x, v prime would be negative sine of x. Since this is product rule, I'm going to multiply backwards and then multiply forwards. So we have cosine of x times 1 over x, or just cosine of x over x, plus ln of x times negative sine of x. And if I'm looking for which answer that is, it looks awfully like C. Cosine of x over x minus ln of x times sine of x. For the next one, they're telling us to find g prime of 3. If you read this function, you get x squared times f of x. And since I'm multiplying two things that have x's in them, I have to use the product rule. So I would say u equals x squared, v equals f of x, u prime is 2x, v prime is f prime of x. If I plug in the value I'm trying to evaluate at now, so I'm trying to find g prime of 3. So if I plug in 3 here, I get 3 squared, which is 9. If I plug in 3 here, I get 2 times 3, which is 6. If I plug in 3 here, I get f of 3. And they tell me in the directions that f of 3 is 4. And if I plug in 3 here, f prime of 3, they tell me in the directions that f prime of 3 is equal to 5. So product rule says to multiply backwards first. 6 times 4 is 24. Plus, since it's product rule, multiply forwards. 9 times 5 is 45. And if I add those two things, I get 69. Answer choice D. This next one says h is f times g, and they want h prime of 3. We've done ones like these before, so I'm just going to start right away. So product rule, u equals f of x, v equals g of x, u prime is f prime of x, g prime, again, v prime is g prime of x. If I want to evaluate right away at 3, f, which is this linear function right here, f of 3 is equal to 4, and g of 3 is equal to 3. So f of 3 is 4, g of 3 is 3. The derivatives, because these are straight lines, are the slopes of the functions themselves. So for the function f, it goes down 1 over 1, down 1 over 1. That means that f prime of 3 would be negative 1. And for g, from here, it goes up 2 over 1. So that means that the rise for g is positive 2 over 1. Product rule says to multiply backwards first. So 3 times negative 1 is negative 3. Plus, if I multiply forwards, 4 times 2 is 8. Negative 3 plus 8 is 5. Answer choice D. For this next one, we have e to the x times sine of x. Because both of those have x's in them, we have to use the product rule. So u equals e to the x. V equals sine of x. u prime would be e to the x. V prime would be cosine of x. Multiply backwards, so you get e to the x sine of x. Multiply forwards, and you get e to the x cosine of x. And that is answer choice C. If they factored out an e to the x, it would be e to the x times whatever's left over, which would be sine of x plus cosine of x. The next one gives us some information about f of 2, f prime of 2. They tell us that g is x cubed times f of x, and they want to know g prime of 2. Again, I have a function of x times another function of x, therefore I have to use the product rule. So my first function u would be equal to x cubed. My second function g would be equal to f of x. U prime is 3x squared. V prime is f prime of x. If I evaluated the number they're looking at, which is 2, I get 2 cubed, which is 8. Over here I get 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. F of 2, and they tell me here that in the directions f of 2 is 2. F prime of 2, and they tell me here in the directions that f prime of 2 is 5. Product rule says to multiply backwards first, so 12 times 2, which is 24. Plus, if I multiply forwards, 8 times 5, which is 40. Therefore, 64 is the correct answer here. Next one. Notice that the same types of problems keep coming up over and over again. So again, another graphical one with another product rule. So u is equal to f of x, v is equal to g of x, u prime is equal to f prime of x, v prime is equal to g prime of x. If I want to know what those values are from the graph, I'm evaluating at 4. So f of 4 is this top function. F of 4 is 2, and g of 4, this bottom function, would be 1. So f of 4 is 2, g of 4 is 1. Remember that the slopes would be the derivatives. So for f, I'm going up 1 over 1, up 1 over 1. So f prime of 4 is 1. For g, I'm going up, what is this? Up 1, 2, 3 over 2. G is up 3 over 2, so 3 halves is my slope. Product rule says to multiply backwards first, so 1 times 1, which is 1, plus, multiplying forwards, 2 times 3 halves. 2 times 3 halves would be 6 halves, which is 3, and then 3 plus 1, which is 4. Answer choice D. For this next one, we have sine of x divided by e to the x, which is the quotient rule. So u equals sine of x, v equals e to the x, u prime is cosine of x, v prime is e to the x. Quotient rule says to multiply backwards first, e to the x cosine of x, minus, multiplying forwards, e to the x sine of x, all over the denominator squared. That's e to the x quantity squared. Now you might notice that none of our answer choices match up with that, and that's because they divided out a common factor from the numerator and denominator. So notice that both of the terms in the numerator had an e to the x, and that I could get rid of one of them in the denominator since there were 2 of them in the denominator. So say goodbye to those e to the x's, and say goodbye to one of them in the denominator, and that leaves us with cosine of x minus sine of x over 1 of the e to the power of x's. And that is answer choice B. All right, and our last page starts now. For this problem over here, it says they're giving us information about f of 9, f prime of 9. Here's this function g. What is the value of g prime of 9? So if you look at this, notice that we have function of x over function of x. That's the quotient rule. So we'll set up a u equaling f of x and a g equaling the square root of x, which I can rewrite as x to the 1/2. U prime would be f prime of x, and g prime would be the derivative of x to the 1/2, which is 1/2 x to the negative 1/2. And if I rewrite that back, it would be 1 over 2 radical x, 1 over 2 square root of x. So if I evaluate now at the value they're looking at, which is 9, I get f of 9, which they tell me in the original problem that f of 9 is 18. F prime of 9, which they tell me in the original problem that f prime of 9 is 7. The square root of 9, which is 3. And then 1 over 2 times the square root of 9, which would be 1 over 2 times 3, which is 1/6. So quotient rule says multiply backwards first, 7 times 3, which is 21. Minus, if you multiply forwards, 18 times 1/6, and 18 times 1/6 is 3. All over the bottom squared. So since the denominator is 3, that would be 3 squared, which is 9. So 21 minus 3, which is 18. 18 over 9, which is 2. Answer choice A. For this next one, they're giving us h equaling 4 times f of x, there's no issues there, but then divided by g of x plus 1. So we have to use the quotient rule. Nothing inside of the numerator, nothing inside of the denominator, but the fact that we have x's on the top and bottom yields the quotient rule. So if I say that u is equal to the top function, which is 4 times f of x, and that v is equal to the bottom function, which is g of x plus 1, to take the derivatives, u prime would be 4 times f prime of x, and v prime would be g prime of x. The derivative of 1 would go away because that's 0. So then from here we would just evaluate it 2. So 4 times f of 2. Well, let's see. F of 2 is equal to negative 3. So this would be 4 times negative 3, which is negative 12. For this next one, we have g of 2, and g of 2 is negative 3, so that would be negative 3 plus 1, which is negative 2. For this next one, we have 4 times f prime of 2. F prime of 2 is 1/2, so 4 times 1/2, which is 2. And last but not least, we have g prime of 2, and g prime of 2 is just 2. So quotient rule says multiply backwards first. That's negative 2 times 2. And negative 2 times 2 is negative 4, minus, multiply forwards, that's negative 12 times 2. Negative 12 times 2 is negative 24, all over the denominator squared, so negative 2 squared, which is positive 4. So negative 4 minus a negative 24 would be negative 4 plus 24, so that's 20 over 4, which is 5. Answer choice D. For this next one, notice that this one's actually a little different. Most of the ones we've done so far have been f of x times g of x, and this one is f of x plus g of x. So there are no special rules we have to use for this one. So when I take the derivative of h prime of x, it's just the derivative of f prime, plus the derivative of g prime. So when I'm actually evaluating at oh, I was looking for a value that they were evaluating at, and I didn't see one, and I guess here's why. So we don't actually need to know a value that we are finding the derivative at, because these are constant functions. So the derivative of f is a constant number, it'll be the same everywhere, and the derivative of g is a constant number, it'll be the same everywhere, because they're straight lines. So the derivative of f everywhere on this line is up 1 over 2, up 1 over 2, up 1 over 2, which is 1/2. So f prime of any number is 1/2. And for g, the derivative of g is down 1 over 1, down 1 over 1, down 1 over 1. So it's negative 1 everywhere on the line. So 1/2 minus 1 would be negative 1/2. Answer choice C. For this next one, it says, shown above is the graph of the differentiable function f, along with the line tangent to the graph of f at x equals 2. What is the value of f prime of 2? So here, let me put it on the point. There we go. Here is the point x equals 2, and this is the tangent line to the graph at that point. So they just want to know what is the value of f prime of 2. So this is kind of more of a conceptual question. So remember that f prime of 2 is the derivative at 2, and the derivative is the slope of the tangent line. So if I can figure out the slope of this line, that is the derivative. So the slope of this line is up 1 over 2, or 1/2. Therefore, answer choice A, up 1 over 2. And again, because that's the slope of the tangent line, then it is the derivative, and the derivative is f prime of 2. For number 73 on my paper, it says, which of the following expressions is the average rate of change on this interval? So remember that to find average rate of change is just the slope. So I need to know what f of 3 is. So if I plug in 3, which actually I'm looking now at our answer choices, and they don't even plug in 3. They just wanted to know, like, conceptually what it would be. So I need 2 points. I need the point 1, comma, whatever f of 1 is. And I need the point 3, comma, whatever f of 3 is. And then if I plug them in the slope formula, y2 minus y1 would be f3 minus f1. Over x2 minus x1 would be 3 minus 1. And that is answer choice C. Pretty easy. And this next one, which is our last problem, says, selected values of a function g are shown in the table above. What is the average rate of change of g over the interval from -3 to 3? So here is the point at -3. Here is the point to +3. To do y2 minus y1 over x2 minus x1, that would be -4 minus 12 over 3 minus -3. So we just have to kind of notice that they didn't actually want us to simplify it. -4 minus 12 over 3 minus -3 is answer choice B. I suppose it could have been in the other order also, but they didn't choose the other order in this case. So B is the correct answer, and that's the last one for today.